In today's video, I'm going to teach you how to create a residual plot in Google Sheets. If you've ever added a trend line and felt confident your data was linear, hold that thought. A trend line can look convincing even when the relationship isn't truly linear. A residual plot gives you the proof by showing how far each observed point is from what your model predicts. We'll start by getting the exact math for your regression line. In Google Sheets, use the slope function and the intercept function on your data. Your y values are the outcomes you're trying to predict, and your x values are the inputs or predictors. Type slope, y range, x range, to get the slope, and intercept y range, as x range, to get the intercept. These two numbers define your prediction formula. Predicted y equals slope times x plus intercept. Place them in clearly labeled cells so you can reference them easily. A quick tip: make sure your x and y ranges line up row by row and don't include headers, otherwise your results will be off. Next, calculate the residuals for every row. Remember, a residual is simply the actual value minus the predicted value. In a new column, create the predicted value for each row by multiplying the slope you just computed by that row's x, then adding the intercept. Right beside it, subtract the predicted value from the actual y to get the residual. Copy the formulas down the entire column so you have a residual for every data point. If you notice positive residuals, your model is under-predicting there. Negative residuals mean it's over-predicting. Keep the slope and intercept references consistent as you fill down, so the formula uses the same model for each row. Now, build the residual plot. Highlight your original x values and the new residuals column, making sure to exclude any headers or blank cells. Insert a chart and choose a scatter chart so each point stands on its own. On a good linear fit, the dots will be randomly scattered above and below the zero grid line without forming a pattern. That randomness tells you the errors are roughly constant and unbiased across x. If you see a curve, a funnel shape, or any systematic structure, the relationship isn't truly linear and you'll need a different type of graph or model to capture it accurately. And that's it. You've turned a simple spreadsheet into a trustworthy diagnostic. That's how you do data science in Google Sheets. Hit that follow button for more pro analysis hacks.